Just minutes after takeoff from Jakarta, Indonesia,
Lion 610, I have no reliable altitude information. All instruments disagree.
pilots fight to control one of the world's newest airliners,
Fly up.
the Boeing MAX 8,
They never really figured out what was going on.
and end up crashing into the Java Sea.
This was a very serious accident.
What does the tracking data show?
Investigators follow an erratic flight path,
They're off course. There are altitudes all over the place.
a history of maintenance issues,
Did we have problems? You bet we did.
and learn about a treacherous piece of hidden software.
Looks like the MCAS kicked in.
What's that?
What they uncover shocks the world and grounds an entire fleet.
The 737 MAX story will clearly be a watershed event in aviation history.
It's just after 5 a.m. in Jakarta, Indonesia, as 181 passengers settle in for a short domestic flight. In the cockpit,
Fuel pumps?
First Officer Harvino performs pre-flight procedures.
Fuel pumps are on.
The captain on this flight is Bhavya Suneja, who has more than 6,000 flying hours. The passengers are on board the latest version of the renowned Boeing 737, known as the MAX 8. David Carber is a former Boeing test pilot.
The MAX is the fourth iteration of the 737, one of the most successful airliners ever. And it was basically born out of a need to improve efficiency and performance.
The MAX 8 has quickly become Boeing's fastest-selling airplane, with more than 300 already in the skies and almost 5,000 in the order books. The one being used on today's flight was delivered to Lion Air 2 months ago.
Lion 610, you are cleared to runway 25 left via Sierra Charlie 1. Contact tower when you are in position.
Lion 610, cleared to runway 25 left via Sierra Charlie 1.
All clear, no traffic. Let's run before takeoff.
Flaps?
Flaps 5. 5 indicated.
Lion Air Flight 610 is a 90-minute journey from Jakarta over the Java Sea to Bangka Island. The low-cost airline operates hundreds of these short flights every day.
Indonesia is the fourth most populous country in the world. And with 17,000 islands, you gotta have an easy way to do short-range transportation to get to those places. And the MAX is the ideal airplane for that kind of operation.
Lion 610, cleared for takeoff, runway 25, contact terminal east when airborne.
Lion 610, cleared for takeoff.
At 6:20,
Rotate.
the MAX 8 lifts off the runway at Jakarta. But immediately there's trouble. The captain's control yoke starts shaking, a warning that the plane is about to stall.
Takeoff config.
Okay, but what?
The pilots can't identify the source of the problem. They have no choice but to continue climbing. The passengers are unaware that the pilots are dealing with anything unusual.
Lion 610, fly heading 248.
Then follow standard instrument departure.
Lion Air 610.
The air traffic controller has no idea that there's an issue in the cockpit. The pilots get a warning that their airspeed indicators do not agree.
Airspeed disagree. What's going on? Should we request a return to Jakarta?
Landing gear up.
Lion 610.
Climb to flight level 270.
Still unaware of any trouble, the controller instructs the crew to continue climbing to 27,000 feet.
Altitude disagree.
The first officer now notices that the altimeters also show conflicting readings.
Acknowledged, altitude disagree.
Lion 610.
Confirm our current altitude, please.
Lion 610, your present altitude is...
900 feet.
The pilots are getting conflicting data about their altitude and their airspeed. Captain Sunasia expects his first officer to carry out the procedure for this situation.
Okay, memory items, airspeed unreliable.
What altitude should I request?
Yeah, request, proceed.
The situation is deteriorating quickly. Climbing above 1,000 feet, the pilots are still unsure of their airspeed. If they fly too slowly, the plane could stall and fall from the sky.
Request clearance to any holding point.
Captain Sunasia wants to get the plane to a point where he can circle and solve the problem.
Lion 610, request clearance to some holding point due to our current condition.
Lion 610, what's the nature of your problem, please?
We are experiencing a flight control problem.
Lion 610.
Where's the airspeed? There's no airspeed unreliable.
It's there.
Got it. Autopilot if engaged, disengaged.
Not every failure is a major emergency, and checklists are designed to grade or evaluate the severity of a system failure. So pilots are trained to methodically go through each step by step.
Autothrottle if engaged, disengaged.
Disengaged.
But the checklist isn't helping.
Okay.
Now flying 5,000 feet above the sea, Captain Sunasia struggles to keep the plane's nose up.
Flight path vector may be unreliable.
Lion 610, turn right, heading 070 to avoid traffic ahead.
Set the pitch attitude. Roger, heading 070.
Lion 610.
You're now descending.
We're having flight control problems and are flying manually.
610, maintain heading 050.
The cabin would have realized that the airplane was not climbing as normal and that it had leveled off, and there was probably some up and down sensations.
Captain Sunasia has been fighting to keep the plane's nose from pitching downwards.
Please, take control for a moment.
He now assigns that task to his first officer,
I have control.
so he can troubleshoot the problem himself.
Oh, it's very...
The first officer is also having difficulty keeping the aircraft level.
There was a wide variety of problems that they had to sort out, and the first thing was what's common between all of these failures, because that's how you start to sort through the problems.
Flight 610 is flying erratically over the Java Sea and becoming increasingly more difficult to control. The lives of everyone on board now depend on the pilots figuring out the problem
I don't know where we are.
and getting the plane to the ground safely.
Line 610, I have no reliable altitude information. All instruments disagree.
Roger, line 610, no restrictions.
When an aircraft declares an emergency, the controller's #1 job is to provide assistance to that airplane.
The controller allows Flight 610 to fly at any altitude the pilots choose.
Please clear 3,000 above and below of traffic.
Okay, will do. What?
Altitude would you like?
It's diving.
It's
It's
diving.
okay, it's okay.
Flight 610 is now speeding towards the sea,
Airspeed.
and the pilots are out of options.
Fly up. Up. Up.
Terrain. Oh, up.
Lion 610, control. Lion Air 610, control. Steadylink 882, please hold on current position. Do you have visual on Lion 610, a Boeing 737 MAX 8?
Negative. No other planes in sight.
"30 minutes after crashing into the Java Sea, the wreckage of Lion Air Flight 610 is located. There are no survivors. Relatives of the passengers are flown to Jakarta for trauma counseling. While they wait for the recovery of the bodies of their loved ones, investigators from Indonesia's Accident Investigation Branch KNKT need to understand why one of the best-selling new aircrafts in the world fell from the sky.
Okay. What does the tracking data show?
Working with data from air traffic control, KNKT investigators focus on the flight path of Lion Air 610.
They're off course. There are altitudes all over the place.
Berikutnya yang kami dapatkan dari air traffic controller data adalah
From this data, we learned that this plane's altitude was fluctuating. It kept going up and down.
ada masalah apa
We wanted to find out why the pilot couldn't keep the plane at a constant altitude.
dengan ketinggian yang konstan.
Investigators need to know if the controller can shed any light on the problems the crew was facing.
They reported that they were having a control issue. Lion 610, what's the nature of your problem, please?
We are experiencing a flight control problem.
Line 610.
That's all he said. A flight control problem. Soon after that, they reported that their instruments were unreliable.
Line 610, I have no reliable altitude information. All instruments disagree.
Roger, line 610, no restrictions. That was about it.
Bagaimana kru berkomunikasi dengan ATC pada hari ini?
From the information we received from the air traffic controller, we didn't get the impression that the pilot was under pressure.
Kemudian bagaimana mereka
The pilot's tone was normal. It didn't seem that he was stressed.
penting yang disampaikan adalah bahwa mereka meminta.
Since the pilots of Flight 610 reported flight control problems and unreliable instruments, investigators wonder if recent maintenance records could explain what brought down the MAX 8 only 11 minutes after takeoff.
Yang kedua bahwa
This flight had some problems with control.
dengan flight control, maka dari
At that point, we needed to learn more about the plane's maintenance history.
kendali.
The angle of attack sensor was replaced the day before?
There are two angle of attack sensors on the 737 MAX 8. The sensors calculate the angle between the plane's wing and the oncoming air. Their data helps determine if the plane's wings are providing sufficient lift.
It's a very important piece of information. The pilots need to have some kind of warning that they are approaching stall, and so the angle of attack sensor is what gives that.
For several days, the left side sensor had been giving faulty readings. It was finally replaced before the plane flew from Bali to Jakarta, one day before the accident. Investigators interview the crew who flew the same plane just hours before the crash to determine if there were any problems with the replacement sensor.
Did we have problems? You bet we did.
Kita mengadakan wawancara.
We conducted an interview with the crew of Flight 043. We learned from them that after takeoff, the crew was also having problems.
Muncul mengalami beberapa kendala.
What investigators hear next is chilling. The captain explains that when he lifted off from Bali, there were simultaneous warnings that his airspeed and altitude indicators had failed.
Airspeed disagree, altitude disagree.
A few seconds later, the MAX 8 stick shaker activated, indicating that a stall was imminent.
Keep climbing. You're up.
All the modern airliners have 3 sets of independently powered essential flight instruments, airspeed and altitude, and also the attitude of the airplane. If there is a discrepancy, you can determine which is providing inaccurate data.
Your instruments are correct. You have control. The failure was on my side, so I handed off. Flaps up.
The captain adjusts his faulty instruments so they display data from the first officer's side.
We're diving. Pitch up. Keep trimming. That's when the plane started diving, over and over.
The captain reports that the plane began a series of uncommanded dives.
Use your trim. That's it.
In order to keep the plane climbing at a constant angle, the pilots set the position of their horizontal stabilizer at takeoff and make minor adjustments during the flight. That's called trim. Trim can either be adjusted by the autopilot or manually by the crew. But every time the first officer tries to trim the nose up, the automated system pushes it back down. The first officer is finding it almost impossible to keep the plane climbing.
The trim system on a modern jet has to be very powerful. The trim in many cases is actually more powerful than the control column.
For some reason, the MAX 8 stabilizer continues to move independently, pushing the plane's nose down despite the first officer's commands.
Let's see what's in the book.
When the automated system moves the stabilizer, it also spins a large wheel that's located between the 2 pilots. This tells them that the system is adjusting the trim on its own.
When the captain bent down to look at the checklist manual to solve the problem during this flight, the 3rd crew was the one notifying the pilot that the trim was moving abnormally.
Runaway stabilizer. Moving switches to cutout.
The crew realizes the stabilizer's automatic trim system is malfunctioning. It's continually pushing the nose down. Disengaging the system resolves the issue.
When they cut out the trim switches, the system stopped doing nose-down trim.
Moving the switch to cutout pretty much solved it.
The investigators learned that the previous crew then did something astonishing.
So, we kept going.
You kept going.
Apabila kembali Denpasar,
If they had decided to return and land in Denpasar, it would have taken only 5 to 10 minutes, and they could have landed safely.
berhadapan dengan
But they decided to continue flying to Jakarta.
Line Air 43, we'll continue on to Jakarta.
Following a near catastrophe, with unreliable instruments and the stick shaker blaring, the crew elected to continue the 90-minute flight to Jakarta.
It surprised all of us that they continued the flight.
The crew managed to make a safe landing at Jakarta and reported the problem to maintenance personnel.
I reported the issue and filled out the flight maintenance log.
If the airplane experiences an abnormal or an unusual system failure, it goes into the maintenance log.
Airspeed and altitude disagree, but not a word about the stabilizer problem?
Investigators are surprised to learn that the captain of the previous flight said nothing about the out-of-control stabilizer or the action he took to correct it.
Runaway stabilizer. Moving switches to cutout.
The lives of the passengers and the crew that follows you is basically dependent on you filling out the paperwork correctly.
Good morning.
Good morning.
They're done loading, so we should be able to get out of here on time today.
A few hours later, the passengers and crew of Flight 610 boarded the aircraft with no knowledge or warning of the potential problems faced by the previous crew hours earlier.
Fuel pumps?
Fuel pumps are on.
Did a repeat of the problem on this aircraft result in the deaths of the 181 passengers and 8 crew? It takes 3 days for search and rescue teams to lock on to the signal coming from the MAX 8's flight data recorder. Divers recover it from a depth of 115 feet. The recorder has preserved data from the accident flight and 18 previous flights, covering almost 1,800 different parameters.
Master caution goes off as soon as they leave the ground, probably because airspeed and altitude don't agree. Stick shaker activates here.
The data shows a repeat of the problem on the previous flight. Faulty readings caused by a discrepancy between the left and right angle of attack sensors.
Dari data flight data recorder yang kami dapatkan.
From the FDR data we received, we learned that this plane had faulty angle of attack readings that affected both flights similarly.
Dua penerbangan ini sangat mirip.
Left and right angle of attack values are off by 21 degrees for the entire flight.
Hingga kami mencurigai apakah
We suspected the new angle of attack sensor installed in Bali was either faulty or the installation process was done incorrectly.
yang tidak sesuai.
The mechanic who replaced the sensor before the flight from Bali to Jakarta failed to ensure it was calibrated, which resulted in faulty readings.
There's a procedure that would have shown it was erroneous and that it was bad. They signed off that they did it. They could not have done it.
On the MAX 8, the angle of attack sensor doesn't just measure the airplane's angle.
Altitude disagree.
It helps calculate precise airspeed and altitude.
That explains why airspeed and altitude disagreed throughout the whole flight.
The malfunctioning sensor on the captain's side resulted in a difference between the left and right side speed and altitude displays.
Then there's this.
The data clearly shows that for every nose-up trim input, there was a corresponding automatic nose-down trim input.
Sounds like what the crew of Flight 43 described.
The data shows investigators that for some reason, the plane's automated trim system was repeatedly dropping the plane's nose while the pilots fought to lift it.
26 separate nose-down commands. This doesn't look like a runaway stabilizer to me.
Runaway stabilizer is a common malfunction of the trim system, usually resulting in one continuous uncommanded movement of the stabilizer.
NTSB juga membawa tim dari
The NTSB brought a representative from Boeing to help us in our investigation. We asked him to explain why, in both Flight 610 and 043, the same plane continued to pitch down.
pesawat ini terus-terusan menunduk.
We're trying to understand these automatic inputs.
Looks like the MCAS kicked in.
What's that?
Boeing points to an obscure automated system known as MCAS, the Maneuvering Characteristics Augmentation System.
Itulah pertama kali kita
That's when we first learned about the MCAS.
MCAS.
To understand what could have caused the crash of Flight 610, investigators need to go back 7 years to 2011, when Boeing first announced the development of the MAX 8.
The 737 MAX was basically born out of a need to improve the performance and sales of the 737.
In 2010, Boeing's main competitor, Airbus, unveiled the A320neo, a fuel-efficient short-haul airplane. It was an immediate hit with airlines at a time of rising fuel costs.
Boeing was caught by surprise. The A320neo was significantly more fuel efficient. So all of a sudden they were faced with a dilemma. Do you design a new airplane, a 4 or 5 year project, or do you modify the existing 737?
But there were problems with taking a plane that was designed in the 1960s and turning it into a fast and fuel-efficient aircraft.
To improve the performance of the MAX, they decided to install more fuel-efficient, larger engines.
The only way to make those larger engines fit was to slide them forward on the wings.
The design engineers had a problem that the ground clearance from the engines, and on 737 you can't increase the size of the main landing gear because of the size of the wheel wells. It has to fit there. So the only thing they could do was to move the engines further forward and up.
That solved one problem, but created another. It caused the 737 to pitch up at low speeds, particularly when it was already in a nose-up position like during takeoffs.
So they created software that would recognize the airplane approaching stall and artificially force the nose down. And logically, they turned to the trim system to do that.
And that's the problem you solved with MCAS?
Yes, it made the MAX handle like any other 737.
MCAS was designed for a very low probability event.
It's diving! It's diving!
It's okay.
How are they trained to respond?
Well, they weren't, not specifically.
Fly up! Up! Up!
Could Boeing's high-tech solution to a design problem have inadvertently put thousands of passengers around the world at risk? In order to eliminate the need for costly pilot training, Boeing had to convince authorities that the MAX 8 handled the same way as all previous 737s.
Different handling characteristics will automatically require time in the simulator and extra training.
Boeing argued that since MCAS operated in the background without the need for any pilot input, it didn't affect the airplane's handling.
Not a word about MCAS here.
Boeing never included mention of MCAS in the flight control manuals. They argued that since the system was not under control of the crew, it should not be included.
It's like the system doesn't even exist.
Boeing menganggap bahwa MCAS ini memenuhi syarat.
Boeing thinks that it's an automatic system for safety purposes and has nothing to do with pilot operation.
Bisa dikendalikan oleh pilot.
According to Boeing, the MCAS software would automatically move the plane's stabilizer to push the plane's nose down if it started to pitch up under very specific circumstances.
It only kicks in when these three conditions are met.
Boeing explains that MCAS only activates when it senses that the angle of attack is excessive, when the autopilot is off, and when the flaps are retracted, an extremely rare combination.
Professional pilots don't typically stall airplanes. So the likelihood of an MCAS activation was thought to be extremely low.
This is the data from both flights.
Tragically, the data shows that because of the faulty maintenance on the angle of attack sensor, Flight 610 ended up meeting all three conditions.
Ini yang kemudian kita melihat bahwa
The series of problems occurred when the left angle of attack sensor was replaced in Bali.
sensor sebelah kiri di Bali.
Investigators dig deeper into the data and discover the MCAS system had no failsafe.
MCAS diputuskan
The MCAS installed in the plane relied on only one sensor.
satu sensor.
MCAS only took data from one angle of attack sensor, not both. Most protection systems are designed with redundancies,
Your instruments are correct. You have control.
so a single failure doesn't result in catastrophe.
Flaps up.
What Boeing did not adequately do was assess all of the other failures that that single component would have.
The faulty angle of attack sensor wrongly showed the plane pitching up steeply. The autopilot was disengaged for the entire flight. And then right here, they retract the flaps. Exactly the same as the previous flight. Now, that's when MCAS kicks in and starts pushing the nose down.
Up to this point, the crew only had a minor instrument problem. By raising the flaps, the pilots unknowingly triggered a much more serious problem.
We assumed the pilots would know how to respond.
Boeing made the assumption that pilots would respond to the uncommanded MCAS inputs by disengaging the automatic trim.
The Boeing assumptions were that the pilots would instantly recognize the inadvertent MCAS activation and treat it within 3 seconds.
Investigators examined the flight data of the previous Lion Air flight to see how that crew reacted to the MCAS activation.
The first MCAS input on Flight 43 is here. The captain pulls back on his control column and applies manual trim, then fights against the MCAS for 3 minutes and 40 seconds before hitting the Cutout switch.
I think the assumption that they were going to recognize and act within 3 seconds was very optimistic, if not unrealistic.
Lion 610, I have no reliable altitude information. All instruments disagree.
Unlike the previous crew, the pilots of Flight 610 struggled with the problem for more than 10 minutes.
Fly up, up, up!
And never made the connection to a runaway stabilizer. Investigators need to understand why two crews facing an identical problem reacted so differently. Investigators struggle to understand why the pilots of Lion Air Flight 610 lost control of the aircraft. After nearly 3 months of searching the ocean floor, the cockpit voice recorder is finally recovered and taken for analysis.
CVR dah merupakan kunci dari
The CVR was the key to our investigation. Together with the FDR data, the CVR could reveal all the mystery in our investigation.
seluruh rahasia mengenai investigasi ini.
Lion 610, cleared for takeoff.
Investigators hope the recording will help to explain why the crew of Flight 610 couldn't identify the problem and take corrective action to fix it.
Rotate. Takeoff config. Okay, but what?
The faulty angle of attack sensor triggers a series of warnings as soon as the plane lifts off.
Airspeed disagree. What's going on?
Should we request a return to Jakarta?
Landing gear up.
Beberapa menit setelah
After takeoff, the MCAS system was activated and their plane started to pitch down.
The captain has noticed that the plane's stabilizer is now automatically trimming the nose down and does what Boeing assumed he would. He pulls back on the control column and uses manual trim to counteract the computerized inputs.
Okay. Boeing was right about that.
But the captain never mentions the trim problem. He and his first officer are focused entirely on their faulty airspeed and altitude readings.
Where's the airspeed? There's no airspeed on Reliable.
It's there.
Got it.
disinilah terjadi perbedaan.
This is where we found significant differences between Flight 043 and 610.
It takes First Officer Harvino nearly 2 minutes to locate the appropriate checklist for mismatched airspeed.
I think the first officer was pretty well task saturated. And one of the things that task saturation does in humans, it limits our ability to communicate. We don't hear well and we don't verbalize things very well.
Flaps up 4 degrees and 75% N1. There it is.
When the automated trim system pushes the nose down, the large wheel makes a characteristic sound.
When the trim wheel moves, it makes a sound like a freight train. It's meant to be noticeable.
Following a Reliable. Attitude, N1.
Ground speed, check.
They still don't notice it. Wrong about that.
He didn't put it together that every time he trimmed up, the MCAS system was trimming it back down.
34 times. He applies nose-up trim 34 times and doesn't think to wonder why. They did not recognize the problem and take the corrective action Boeing predicted they would.
In this particular case, Boeing made assumptions about design and pilot experience and training that didn't add up.
Please, take control for a moment. I have control.
Investigators now hear another crucial difference between Flight 610 and the previous flight.
That's it? Please take control? Not a word about the fact that he's had to make more than 30 trim inputs.
I think the captain was very frustrated with the first officer.
Oh, it's very...
And I'm sure he didn't really want to hand it over to the first officer, but he felt that he needed to in order to figure out what was going on with the checklist.
But because there's no mention of MCAS in the manual, there isn't a checklist for the crew to follow.
It's diving! It's diving!
Okay.
With no warning from the captain about the need for repeated nose-up trim, the first officer quickly becomes overwhelmed.
Sadly, this first officer was pretty well overwhelmed, and as the system trimmed the nose down, he was not nearly aggressive enough in responding to that.
Namun demikian di penerbangan 610
In Flight 610, the pilot didn't deactivate the automatic trim, and the plane's nose kept coming down because of the MCAS, and it didn't stop until the plane crashed.
1 minute after taking control, the first officer watches helplessly as the plane plunges towards the Java Sea. KNKT investigators discover that Boeing's assumptions of how pilots would recognize and overcome an uncommanded nose-down trim on the MAX 8 were fatally flawed.
They sure didn't act the way Boeing said they would.
Here it is. Without requiring exceptional skill or strength.
Investigators soon learn why Boeing's assumptions about how pilots would react were so wrong. To certify the MAX 8, Boeing assured the FAA that an average flight crew would be able to override the MCAS system.
So were these guys average? Captain passed all his checks. Looks like a competent pilot. This guy is a whole different story.
Investigators are surprised by the first officer's background.
The first officer on Lion Air Flight 610 had had challenges in training. He had trouble staying up with the airplane, understanding the complexities. His manual flying skills were not optimum, and he required additional training.
It's diving! It's diving!
It's okay, it's okay.
Flight 610 proved that Boeing was wrong about how pilots would react to an MCAS failure.
Fly up! Up! Up!
They never really figured it out. And then the captain gave control to someone whose manual flying skills were not going to save the day.
As a result of the accident, Boeing issues new guidelines for MAX 8 pilots, informing them about MCAS and detailing the procedures to follow in the event it triggers an uncommanded nose down. The bulletin advises pilots to apply manual trim and to move the stabilizer trim switches to cutout.
This was a reinforcement to the pilots that says there is a system on the airplane that can move the trim. If it does so, treat it as a runaway stabilizer.
Hey, turn the TV on?
Our breaking news. An Ethiopian Airlines has crashed shortly after takeoff from Addis Ababa.
The belief that Boeing's advisory would prevent another similar accident is shattered 4 months later when another MAX 8 crashes.
Dead.
Flight tracking data shows that Ethiopian Airlines Flight 302's altitude fluctuated throughout the flight. There's immediate speculation that once again, Boeing's MCAS software is to blame.
In both accidents, the MCAS activated, causing this nose-down trim situation to occur repeatedly. And in both cases, the crews let the airplane accelerate far, far greater speed than it should have been. Put those two together and the controllability of the airplane was lost.
This time, the pilots knew about MCAS and what to do in case it activated, yet they still couldn't control the airplane.
Boeing realized, well, if this crew can't handle it, then other crews won't.
In spite of the FAA's assurance that the MAX 8 is airworthy, regulators around the world ground the global MAX 8 fleet until the problem with MCAS is fixed.
The main thing in our mind was we worried that all of the Boeing 737 MAX 8s that are currently flying all over the world might have the potential to suffer the same catastrophe.
The FAA eventually follows suit.
But our concern isn't with the mistakes that were...
A U.S. congressional investigation determines that Boeing made faulty technical assumptions and errors in judgment, which led to these accidents.
Didn't know about this is unacceptable.
Boeing insists it's learned from these incidents and is determined to make the MAX 8 safe and regain public trust.
Boeing has committed to making it easier for pilots to override the MCAS system. Once that override is activated, the system will not continue to re-engage. And they're developing a training program to familiarize pilots with MCAS.
The 737 MAX story will change forever how airplanes are certified. And the 737 MAX will clearly be a watershed event in aviation history.